Physics students, good afternoon. Mr. Fugit here. Today in this video, we're going to be looking at some sample problems from your homework assignment number 3, which covers over our study of kinematics. So the past couple of weeks, we've been looking at the study of really how things move, and your homework assignment covers really different problem sets and scenarios of how objects are moving. So today we're going to be looking at problem number 1 from homework 3. Now I'll read it for you, just so you know, as a reminder, your problems are going to have different values than the ones that I read, but the process will be effectively the same. So problem number 1 says this: a car traveling in a straight line has a velocity of 2.93 meters per second at some instant. After 5.13 seconds, its velocity is now 12.7 meters per second. What is its average acceleration in this time interval? So I'm just going to start by really listing out the variables that I could potentially be dealing with here. Delta x, that's our displacement, how far something travels. V naught, my initial velocity, in whatever scenario I'm dealing with. V1 is going to be my final velocity in this scenario. A is my acceleration, and T is my time. Okay, now that I have my 5 variables listed, I'm just going to look back at my problem statement and identify, what do I have here? So I'm told a car is traveling in a straight line and has a velocity of 2.93 meters per second at some instant. I'm going to assume that's just my starting velocity, because it's really the first one I'm given, and I'm told I'm just traveling down the road at this velocity. Then I'm told after a certain time, 5.13 seconds, its velocity goes up. So I'm going to put in my time interval, 5.13 seconds. Now during that time interval, my car is going to speed up to now 12.7 meters per second. I'm going to call that 12.7 meters per second my V1, or final velocity. So effectively what's happening here is you're traveling down the road at some speed, you hit the gas, your speed increases. And you do that for roughly about 5.13 seconds. Now we're asked here for the average acceleration. So I'm going to put a question mark by acceleration as well as a star, because that's the variable that I don't know that I want to find. How quickly does my car accelerate? Now, nowhere in this problem am I told anything about my displacement, how far this car is going. So that's the variable that I don't know, that I'm also not really that concerned about. Okay, so now that I have my variables listed out, what I'm going to do is I'm going to try to identify which equation is probably going to fit with this scenario. Okay, so what I would do is I'd look at my kinematics equation sheet, okay, and I'd look over at delta x, which is the variable we don't know and that we're not concerned about. If I find delta x and I come down to where it's blank or empty and I come over to the left, that should tell me I'm going to use equation number 1 in this scenario. So what I'm going to do is I'm going to write out equation number 1. It looks like this: V1 is equal to V naught plus acceleration times time. You'll notice here, this equation doesn't have our delta x variable, which we're not concerned with. So I'm going to take this equation and the variables I have, try and solve for acceleration. Let's come to a new page. So V1 is equal to V naught plus acceleration times time. Now if I come back, I'm just going to plug in what I know. My V1, 12.7 meters per second. It's always wise to make sure to include our units in our equation. Is equal to V naught, 2.93 meters per second, plus my acceleration, A, which I don't know, so I'm just going to leave that variable in my equation, times time, which if I come back, 5.13 seconds. Again, your values will be different, but the process should be the same. Now my goal here is to try to solve for this acceleration value, A. That's what we're looking for. And don't be confused by the term average acceleration. That simply just means we're assuming the car's acceleration is constant over this time interval. Okay? Don't worry about that word average. So to get A by itself, the first thing I can probably do here is get rid of this 2.93 meters per second. So I'm going to subtract that value on both sides of my equation. Okay? Another helpful clue is that notice the units, meters per second, are the same for this quantity as well as this one on the left, meaning I can add or subtract them to help simplify my equation down. If my units are not the same, I cannot add or subtract them. Okay, that's only for addition and subtraction. So what I'll do here is I'll take 12.97 and I'll subtract 2.93. Excuse me. It should give me a value of about 9.77 meters per second. And that's going to be equal to whatever's left on the right-hand side of my equation. My acceleration times 5.13 seconds. Once I'm here, now my equation looks a little bit more simplified and easier to solve for my value, A, acceleration. Now to get A alone, what I probably need to do here is divide both sides of my equation by 5.13. Notice I'm putting the units into my equation just so that I can keep track, make sure I have the correct units at the very end. So this 5.13, since it's on top and bottom on the right side, will cancel out. And we'll be left with a value that looks like my acceleration, A, is equal to 9.77 meters per second divided by 5.13 seconds. So let's plug that in. I should get a value of my acceleration of 1.90 meters per, well, let's be careful here. I had meters per second. I divided by seconds again, so I should now have not meters per second, but meters per second squared. And meters per second squared. And that should be my clue. That unit, meters per second squared, always goes with acceleration. Should always be in meters per second squared. Okay? Those units can serve as a guide to make sure we're solving for this variable correctly. Okay? Acceleration should always be in meters per second squared. Okay? So that should be my answer for our problem. And if we want to take this a little bit further, we know 1.9 okay, is within the range of values for acceleration we've talked about. Our high-end value should be about 7.3, 7.4. Our low-end value should be about 1.4. So this tells us our car has a much lower value for acceleration than most. This is going to be on the lower end. Okay? So hopefully that gets you started in the right direction on problem number 1. Okay? Make sure pay close attention to the values that you're given as well as your units. Okay? Good luck.